What's up, Algebra 1 students? This is lesson 36. Our objective is how to use proportions to solve polygons. So I guess the first thing we need to know is, what does it mean to be similar versus congruent? Similar shapes are shapes that are the same shape but not necessarily the same size. They could be, but they don't have to be. So same shape, kind of different sizes. Congruent shapes are shapes that are the same size or same shape and same size. So they're exactly the same. On similar, which we're dealing with here, that's why we use this little symbol. For similar, we use this one for congruent. So this says triangle ABC is similar to triangle DEF. Well, the order of this matters because that tells us that A is going to be congruent to D. That angle is going to be the same. B is going to be congruent to E, and C is going to be congruent to F. Because notice those are in the same position: A, D, B and E, C and F. Okay. That also tells us that their side lengths are proportional to each other. Meaning if I take AB and divide it by DE, be the same thing as taking BC and dividing it by EF, right? And same thing as saying AC divided by DF, or CADF. So you can kind of get those proportions there if we know that they are similar. So let's see if we can use what we just learned to go ahead and solve these. It says find the measure of angle Q and Z. So looking for this angle and also this angle. Well, we know that these two are similar because we were told that they're similar. And if they're similar, that means Q, we need to see what's in the same position as Q. Well, over here is the X. So we know what X is, so that means the measure of angle Q is going to be the same as the measure of angle X, which is 60 degrees. The measure of angle Z, let's see which one's in the same position as Z. Well, S is in the same position, and S is 120, so that means Z is going to equal to 120 degrees. Okay. B says find the scale factor of PQR, the one on the left, to this one. So what it's saying is, what number would I have to multiply one of these sides by to find the length of one of these sides? So I notice that PQ doesn't have any length, and neither does this, so that doesn't help us. This one has a length, but the corresponding side does not. This one has length, but this one doesn't have length, it's just a letter. So it means I'm going to have to use this one and this one because these both have a number or a length given on both of those. So what I'm wondering for part B is I'm saying 8 times what, we'll call it X, is going to give me 2. So to solve that, I'm going to divide both sides by 8, which is going to give me X is equal to 2/8. But reducing that is going to give me 1/4. So the scale factor from the one on the left to the one on the right is 1/4. Okay? If I'd said from the one on the right to the one on the left, I would have said 2 times what will give me 8. So the scale factor going the other direction from here to here would have been 4. Okay? So now we're going to go to part C. It says use the scale factor we just found, the 1/4, to find QR and WZ, this length. So let's go with WZ first. This is 12, and I'm trying to find this one. So if I multiply this by this, multiply 12 by 1/4, it should give me this. So then I will say that WZ is going to equal to 1/4 times 12. So 4 goes in that 1 time, goes in that 3 times. So WZ is equal to 3. WZ is equal to 3. So this length over here is equal to 3. Okay? And then we need to find QR. Well, again, this is going to be a little bit different because now we're saying I have 3 and I'm trying to get to there. It'd be like saying 2 trying to get to there. So this way I have to multiply by 4 instead of the 1/4. So what's 3 times 4? So that means QR is going to equal to 3 times 4, the scale factor, which is 12. So QR is equal to 12. Okay. This is like example 2. It says, how tall is the basketball player? And we have a nice little diagram here to help us find it. We have a normal person who is 5.5 feet tall, or 5 foot 6 inches, and their shadow is 4 feet long. A basketball player, we're trying to find its height, casts a 5 foot long shadow. So how tall is a basketball player? Well, let's see if we can set up a proportion. The height of the basketball player over 5 feet, the length of his shadow, should be the same as the height of the normal person, 5.5, over the length of their shadow. Okay? And that's because the rays from the sun are all parallel at the same time of day. And so the triangle here would be similar to the triangle there. Okay? So now we have a proportion, so let's see about solving that cross multiply. 4h is equal to 5 times 5.5, which is 27.5. Divide both sides by 4. So the height of the basketball player is approximately 6.875 feet. That's how tall he is. 6.875 feet, so almost 7 feet tall. Wow, that's a tall basketball player. Alright, this is like example 3. It says, in a scale drawing, a kite is designed so that the length of the tail is 9 centimeters. If the scale of the drawing is 1 centimeter to 10 centimeters, what is the length of the actual kite tail? So in the drawing, in a scale drawing, the kite length is 9 centimeters. So this is the length in the drawing divided by the real length. That's what I'm looking for. And I know I have this scale factor here. This is the length in the drawing, so I'm going to put that one on top, over the length in real life, 10 centimeters. Okay, my centimeters will reduce, and so I'm going to cross multiply. So I'm going to get 90 is equal to x, so the real length is going to be 90 centimeters. Okay. Your homework, in case you haven't seen it already, so on page 277, you're going to do all the 36s, all the 35s, and 3 more of your choice. Good luck.